Good morning all. Terrestrial magnetism. So terrestrial magnetism means the study of Earth's magnetic field. The study of Earth's magnetic field. Right? Now, let us talk about first about magnetic elements. Right? Now, magnetic elements, we are having three magnetic elements. Before saying that, let us define what are magnetic elements of Earth. Magnetic elements of Earth are that quantities which determines magnetic field of Earth at a place. So magnetic elements are that particular quantities which determines the magnetic field of Earth at a place. So magnetic elements are declination, dip, horizontal, component of Earth's magnetic field. Right? Next, intensity of field. Now one by one let us define them. First one, let us define declination. Right? So declination means, before saying declination, let us talk about the directive. Before talking about this, the directive property of magnet. Directive property of magnet means, we know that we are having geographical north, geographical south, east, west. For Earth we are having four sides: east, west, north, south. Right? Now anywhere, at any place on the Earth, let us tie a bar magnet with a thread and suspend it. Okay, suspend it. You will find that this bar magnet oscillates and comes to the rest position. So rest position means, how it will come means, the north of bar magnet will face geographical north, south of bar magnet face geographical south. So anywhere, if you do, at any place on the Earth, if you do, you will see this situation only. So this we call it as a directive property of magnet, and due to this directive property of magnet only, we use these magnets in shipping, in ships, to show the direction. Okay. Now next, the second thing which we have to discuss before the declination is, now earlier scientists said that Earth is itself a huge magnet. Earth itself is a huge magnet. Then how to prove? How to prove means, earlier they just took, you suppose it as magnetic needle. They pivoted the magnetic needle at the center. Pivoted means fixing the magnetic needle at the center. What they did in first point, they pivoted this bar magnet at center. Now in such a way, let us see just an example I am showing just for your idea. In such a way, now they pivoted in such a way that this particular magnet will do free oscillations. Okay, in such a way it will do free oscillations. Okay, and now after doing oscillations at one particular time, it will come to the rest. Then what we will think, that rest position must be also in such a way, but instead of such vertical direction, coming to the rest position in such vertical direction, they observed that at one place, this is the original position of magnet, at one place it was inclined in such a way, dipped down. Okay, at some other place they found that it dipped in such a way. So at which positions means, this is in northern hemisphere. They found that north of the magnet has dipped down. Okay, it has dipped down. And in southern hemisphere, the south pole has dipped down. Means they find the deflection in the magnetic needle. Sorry, not the bar magnet, magnetic needle. They find the deflection in magnetic needle. So this deflection proves that magnetic field is present on the earth. So they said that earth itself is producing that magnetic field. So they said that earth itself is a huge magnet. Earth itself is a huge magnet. So what they did, they took a magnetic needle, right? They pivoted at the center in such a way that it can do free oscillations. So they placed this system, this arrangement at different places on the earth. In northern hemisphere, they saw that north of the magnetic needle has dipped down, and in southern hemisphere they saw that south of the magnetic field has a magnetic needle has dipped down, showing the deflection of magnetic field, which shows that, or which proves that earth itself is a huge magnet. Now next, let us define what is declination. Now earth, geographical north, geographical south. The straight line which joins geographical north to geographical south, we call it as geographic meridian. What is geographic meridian? A straight line joining, an imaginary straight line joining geographical north and south. Now only what we said, earth itself is a huge magnet, so earth also has north and south poles, and these north south poles, there will be an imaginary straight line drawing this joining this north and south poles of earth, north and south poles of earth. And this line, you see, it is inclined to geographic meridian, and this straight line joining north and south poles of earth, we call it as magnetic meridian. Now see the position. Magnetic meridian is in such a way that it is making certain angle theta with geographic meridian. So this angle we call it as declination. So what is declination? The angle between geographic meridian and magnetic meridian, straight lines joining this geographic north and geographic south, and magnetic Earth's north and south poles. This we call it as declination. Now next, let us talk about dip. Okay, now this is the Earth. So we said that Earth itself is a huge magnet. So this is the I, the resultant intensity of Earth's magnetic field. What is I? Resultant intensity of Earth's magnetic field. So the fourth term we got intensity of field, that is I is the intensity, resultant intensity of magnetic field. Now let us resolve this I into two components. One is parallel component or horizontal component H. So what is H? Horizontal component of Earth's magnetic field. So we got the definition for the third one also. So if we think it as OH becomes the horizontal component of Earth's magnetic field, and OV it is vertical component of Earth's magnetic field. So OH, now here I, actually this I is the resultant intensity of magnetic field. So we divided I, resolved I into two components, horizontal component along OH, vertical component along OV. Now this angle alpha between horizontal component of Earth's magnetic field and total or resultant intensity of Earth's magnetic field, we call it as dip, or we can also call it as inclination. So what is dip or inclination? The angle between horizontal component of Earth's magnetic field and resultant intensity of Earth's magnetic field, we call it as dip or inclination. Now this horizontal component, how we will write? OH is equal to H equal to I cos alpha. Vertical component OV equal to V equal to I sin alpha. So V by H is equal to I sin alpha by I cos alpha. I sin alpha by I cos alpha. I strikes off. So V by H is equal to tan alpha. The ratio of vertical to the horizontal component of Earth's magnetic field will be equal to tan alpha. So these are about the elements of magnetic field.